Alright, in tonight's video we're looking at the solubility curves which are found at the back of the grade 9 advanced science booklets. This is as we go into the third unit for the course on solubility. The solubility curves graph is something we're going to use a lot in this unit. So as in any graph, it's important in order to understand what it's telling you to examine the axes. On the y-axis, the vertical axis of this graph, we see solubility measured in grams per 100 milliliters of water. So these are solutions that are aqueous. Water is the solvent in these solutions. And solubility, you recall, is the maximum possible concentration that a certain solute could have. So we're using primarily salts as solutes, not just table salt like sodium chloride. There are other salts, and almost all of the solutes on this chart are salts. And the graph is showing us their solubilities. Now the x-axis is showing us temperature in degrees Celsius. So therefore we're looking at how the solubility is changing as you increase the temperature. Now for all of the graphs, almost all of them, you can see there's an increase in solubility, although for one, the one at the very bottom on the right hand side, the NH3, it's showing a decrease in solubility. Some of them increase dramatically in solubility. KNO3 is the one that has the greatest change in solubility as you heat up the water. And some, the change is not so great. So for example, sodium chloride, NaCl, has a pretty small change in solubility. So those are just some things that are just jumping out at us as we just glance at the chart. Now I've already highlighted some of the formulas on the right-hand side of the chart, but let's go down. If you have your own data booklet, or your own science booklet rather, open, you'll want to write down some of these names directly on the booklet. So these are mostly salts, and this is a little bit of chemistry that would be unfamiliar with you, so I'm just going to tell you the names of these compounds. When you see a compound starting with the letter K, that's the symbol for potassium. And NO3 is an ion in chemistry called nitrate. So this guy's name is potassium nitrate. The next one down is NaNO3, so potassium nitrate is the top of your chart on the right-hand side. The next one going down on the right-hand side of the chart is NaNO3. Na on a periodic table is the symbol for sodium, and we already know that NO3 is nitrate, so this is sodium nitrate. All right, the next one down on the chart is KCl. We've already said that K is the element symbol for potassium, and Cl is the element symbol for chloride. So this is potassium chloride. These are all different kinds of salts. Then comes sodium again, the symbol Na, and bonded to Cl, this is sodium chloride. This is the most common type of salt that people have heard of. This is table salt, the salt that you would normally eat. Then comes a formula that's a little bit more complicated. It starts with sodium again, and then it has this HCO3 attached. The HCO3 has a couple of different names, but we're going to use its older name here. We'll call it sodium bicarbonate. If you were in a chemistry class, you'd probably call it sodium hydrogen carbonate, but we'll call it sodium bicarbonate. That's its older, more common name. It's basically baking soda. That's what sodium bicarbonate is, baking soda. The last compound, the NH3, so we've gone down the list on the right-hand side of the table. Now we've reached this weird one, the NH3, because its solubility fell as we were increasing temperature. This guy's name is actually, it's not actually a salt. This is something we'd call in chemistry a covalent compound, but you don't need to know that for grade 9 science. Its name is ammonia. And you might want to note for yourself that unlike the salts that were up above, it is a gas. The salts at room temperature are going to be solids, and the ammonia is a gas at room temperature. So as you can see, the ammonia solubility fell, partly because it's a gas, while the other solubilities increased. Those were solid salts. All right, so that's just some basic nomenclature or naming of compounds. And as you go through the problem solving in this unit, you're going to be expected to know those different names. You might not be told the formula, but you'll have to know that NaNO3 is sodium nitrate. Now, one of the first things that you have to learn how to do is just read this graph. So, for example, let's take a very simple question. Pick a temperature, so 40 degrees Celsius. We're going to calculate the solubility, well, not calculate, but determine the solubility of, and let's pick one of our salts. Let's take potassium nitrate. All right, so we're given a temperature, 40 degrees Celsius. We're given a salt, in this case potassium nitrate, and we just want to know what is its solubility. So the first thing I'll do is I'll just highlight the curve that we're looking at. So the potassium nitrate curve is this one that shows the most dramatic rise in solubility. That's the KNO3 curve, so don't look at any of the other curves. Next, let's find 40 degrees Celsius on the x-axis. So 40 degrees Celsius is down here. I've just circled it. Now, on that axis, go straight up. You're doing this with just your finger or a pencil. Try not to write on your own chart. And then we're going to go over to the y-axis, and we're going to estimate what the solubility is. Now, be careful in estimating. People that do it quickly will make little mistakes. So the solubility here looks to be very close to 60 grams per 100 mils. But if I'm looking very closely, I'm going to say it's actually a little bit above 60. So notice there's 60 and 70 on the y-axis. The little line in the middle is 65. So this is between 60 and 65. It's very close to 60. Probably 61 would be the best answer. So the solubility of the potassium nitrate is 61 grams per 100 milliliters of water. I'll try it again. Okay, this time we'll pick a different temperature and a different salt. Let's say at 80 degrees Celsius, the solubility of, and let's pick a different salt. How about potassium chloride, KCl, is, all right, so this time we're looking at the potassium chloride salt. We want to know what its solubility is at 80 degrees. So we find potassium chloride. Its curve is this one here. Find 80 degrees Celsius on your graph. So 80 degrees Celsius is down here. I've circled it. Go up to the curve, and you can tell when you hit the KCl curve that the solubility is slightly more than 50, right? But it's not at 55, the halfway point between 50 and 60. But it's a little bit closer to 55 than the last one was to the midway point. So I'm going to probably say this one is like 52. 52 grams per 100 mils of water. All right. Now, generally speaking, we're going to give you about a plus or minus 1 when you read the solubility chart. So if I said 52 and you thought 51 or 53, you'd get full marks for that. Okay, but try your best to read it accurately. Try another one at, let's see, well, actually, how about, I'll rephrase this one. So what is the solubility of sodium nitrate in boiling water? Boiling water. So boiling water, there's no temperature explicitly mentioned in that question, but you'd be expected to know that boiling water is 100 degrees Celsius. So really this is saying at 100 degrees Celsius. Now the curve for sodium nitrate sodium nitrate is this curve here on your chart. Find 100 degrees Celsius on the x-axis, so that's this highest temperature, and go straight up until you hit that curve. So that one pretty much hits exactly 180. You might argue it's slightly higher, 181, but it's one of those two. So I'm going to say it's 180 grams per 100 mils of water. All right, so that's just reading the solubility chart. You need to be able to do that to solve higher level solubility problems. Finally, notice that every one of these solubilities that we've written, do you recognize that they're actually unit multipliers? So that's how we're going to use these when we solve problems. If you just said the solubility is 180 grams per 100 milliliters of water, you could say 180 grams of sodium nitrate for every 100 milliliters of water. Or you could say 100 milliliters of water will dissolve 180 grams of sodium nitrate. So the solubility can be written in either way, but notice whichever way you write it, it's a unit multiplier. So if you're given a volume of water, you could calculate with the unit multiplier, the solubility, you could calculate the mass of the salt that could dissolve in that water at a given temperature. If you were given the volume of water, if you were given the mass of salt, then you could calculate the volume of water needed to dissolve that salt at a given temperature, right? So either way, given the mass of the salt, you could find the volume of water needed to dissolve it at some temperature. Given the volume of water, you could find the mass of salt needed to make a saturated solution, the amount of salt that could dissolve in that water at that temperature. So that's where we're headed, but before you can do that, you have to be able to read and interpret the graph. So I hope that helps. Good luck.